Chapter 7, Valuing Stocks. This is the second part, of which this presentation refers to the first subpart. So far, we've seen how to read various things about stocks from Yahoo Finance, aspects such as bid price, ask price, volume of shares traded, previous open, close, 52-week high, 52-week low, dividend yield, market capitalization, etc. We've also seen how to read the market, where the markets have moved up, moved down. We've also seen the meaning of intrinsic value, which is nothing but the present value of future profits. So essentially, the present value of a stock is given as any future sales value plus dividends divided by the respective rate plus 1 to the power whatever the time period we receive the cash flow in. For example, if we sold the stock after period 1 at a price P, received a dividend D, then with a rate of discounting R, the intrinsic value would be P plus D divided by 1 plus R to the power 1. Then we also saw what is the expected return on the stock. Essentially, return is the selling price minus the purchase price plus dividend divided by the purchase price times 100. In this presentation, the following are expected learning outcomes. First, we will see the dividend discount models, of which if there is a constant dividend and no growth, or when there is constant growth, or when there is non-constant growth, how can we value stocks with these kind of attributes? The presentation after this, we will talk about growth versus income stocks. We'll talk about market anomalies and behavioral finance. Now let's look at the pricing of stocks. In this, we assume that the stock is valued for one period. We bought a stock for one period and sold it. The price is given by div1 divided by 1 plus r to the power 1 plus the selling price which we sold it at after 1 year divided by 1 plus r to the power 1, because both these cash flows occurred at the end of the first year. So P0 here is the intrinsic value or the price of the stock today. D1 is the dividend after period 1. P1 is the expected price after the first period. And R is a discounted rate. Here we can call it as a required rate of return from the stock. If we extrapolate this to H periods, then the following happens. We have P0 is div1 divided by 1 plus R, div2 divided by 1 plus R squared, and so on and so forth till div-H divided by 1 plus R to the power H plus PH divided by 1 plus R to the power H. So we can summarize this as time t going from 1 through H of div t divided by 1 plus R to the power t. So this is summed over H periods, the first term here, right there, and the second term is the selling price, PH, divided by 1 plus R to the power H. H being the power because PH was received after H periods. Now let's recall a perpetuity. What's a perpetuity? In a perpetuity, we get constant cash flows of C. And the present value of this perpetuity is C over the discounting rate R. So PV is C over R. Now, this is for infinite periods. Now let's put this in the context of a stock. If we bought a share of any company and wanted to keep it forever, then what happens is we keep receiving dividends from period 1 through period infinity. And the present value of these dividends could be represented by the sum going from t equals to 1 through infinity, that's forever, of dividend received at the period t divided by 1 plus discounting rate to the power t. And this could be represented as a perpetuity whose present value is the cash flow, which is the dividend that we receive, assuming that it's constant at the value of div divided by the discount rate r. So the assumption here is that all the dividends div1, div2 through div-h behave like a cash flow, which is constant, and that's DIV. So a perpetuity really could be no different from a stock that pays a constant dividend, essentially, if we were to hold it forever. However, what happens if dividend grows? And this assumption is fairly reasonable because companies grow over time. Companies like IBM have grown, Microsoft, Apple, etc. So they might be tempted to provide higher dividends to their shareholders. And if such is the case, let's assume that the growth rate is constant at a rate g%. So D1 here could be represented as D0 times 1 plus G. D2 could be D1 times 1 plus G, because every dividend is growing over the previous dividend at the rate G. But wait a minute, D2 is expressed in terms of D1, and D1 from above is expressed in terms of D0. If we substitute D1 by D0 times 1 plus G, we get D2 equals D0 times 1 plus G times 1 plus G, which is 1 plus G squared. So we can extrapolate this to a tth period or the nth period, in which dn will be d0 times 1 plus g to the n, like that. Now, the price of a stock is essentially a present value. So each dividend for a period I or t would be discounted by 1 plus rate to the power t. In this case, dividend 1, div1, would be discounted as div1 divided by 1 plus r, div2 as div2 divided by 1 plus r to the power 2, etc., and so on and so forth, till div-h divided by 1 plus r to the power h. And assuming we sold the stock at the hth period, ph divided by 1 plus r to the power h. Assuming we didn't sell the stock, like in the previous model, then there is no ph. We will keep receiving the dividend, and that dividend will be discounted by 1 plus r to the power that period. So, for example, if we have P0 equals div1 divided by 1 plus r, then div2 divided by 1 plus r whole square, well, that div2 from above can be expressed as div1 times 1 plus g. So I'm substituting that as div1 times 1 plus g. Now div3 can be substituted as div2 times 1 plus g, or div1 times 1 plus g squared. So we are sort of building a pattern here. Let's look at the first term. The first term is div1 divided by 1 plus r to the power 1. The second term is div1 times 1 plus g to the power 1 divided by 1 plus r squared. The power of 1 plus r is the same as the period. The power of 1 plus g is 1 less than the period. Let's see it again. There's div3 here, right? So div3 is div1 times 1 plus g to the power 2 divided by 1 plus r to the power 3. And so on and so forth for infinite terms. Now let's rewrite that again. So div1 divided by 1 plus r, div1 times 1 plus g divided by 1 plus r squared, div1 times 1 plus g whole square divided by 1 plus r to the power 3, and so on and so forth till infinity is the present value of all the cash flows, which is the price of the stock, assuming we never sold it. Now, can we rewrite this? Can we simplify this? Let's try to do it. So P0, I'm going to take out div1 divided by 1 plus r common. If I did that, then in the parentheses, I'd be left with 1 from the first term here. 1 plus g divided by 1 plus r from the second term. Because if I multiply this 1 plus g by 1 plus r with div1 and 1 plus r, I'll get div1, 1 plus g from here, 1 plus r from 1 from here, and 1 from here. So that's whole square. Then div1, 1 plus g squared, and 1 plus r squared. And that final term, infinity. Okay, so P0 is a times 1 plus r squared, and so on and so forth till infinity. I have just replaced div1, 1 plus r as a, and 1 plus g over 1 plus r as big R. So let's see that. Div1, 1 plus r is A. 1 plus G, 1 plus R is big R. So that is 1 plus G, 1 plus R whole squared. That's big R squared. That's the infinity. So my P0 is A 1 plus R squared and so on to infinity, which we've seen from perpetuity. If R is less than 1, then I can express this as A divided by 1 minus R. Now I'm going to replace the A back. A is div 1 divided by 1 plus R. So P0, which was A over 1 minus R, is now div 1 1 plus R times 1 minus R. And if I simplify this, then I get div 1 divided by R minus G. So that's the div 1 there, 1 plus R. And this is called the constant growth model or the Gordon model. The bottom line is, all we need to know is the price today is defined as the first dividend we receive at the end of this year divided by R, the discount rate, minus G, the growth rate of dividends. Now notice here that G has to be less than R, which means that big R has to be less than 1. Let's do some examples. The first example is, if div 0 is 5 and R is 10%, there is no growth. It's just a constant, 0%. So it becomes a perpetuity with a cash flow of $5 every year without growing. So the price of this perpetuity is 5, that is the cash flow, divided by R, 0.1, which is $50. So the intrinsic value of this stock, or the price today, would be $50. That's a simple case. Now let's make this grow, the dividend grow. So div 0 was $5 from above. Growth rate is 2.5%. What is the price? So we can calculate div 1 as div 0 times 1 plus G, which is 5 times 1.025, where G is 2.5%. So the numerator is 5 times 1.025, which is div 0 times 1 plus G, or div 1 divided by R, which is 0.1 from above, minus G, which is 0.025 on the left, and that gives us, on solving, a price of 68.33. So notice that as soon as our stock started paying dividends which are growing, the price of the stock went up from 50 to 68.33. So as stocks pay more dividend, shareholders like it and the price of the shares go up. Now, in the test, suppose we give you price, dividend, and growth rate of the dividends. Can you find out the discount rate? Well, we'll show you how. So if div 0 is 5, G is 2.5%. What is div 1? Well, D1 is D0 times 1 plus G. It is 5 times 1.025, which is 5.125. So why do we need div 1? We'll come to that in a minute. Now the price is given as 68.33 from the previous slide as well. If G is 2.5%, which you've just seen, what is R? Well, we know that P0 is div 1, which is the dividend we receive at the end of this year, divided by R, the discount rate, minus G, the growth rate of dividends. And our target is to find that R sitting in the denominator. Since we know the price and don't know the R, we interchange these two parameters. So we have R minus G equals div 1 divided by P0. We take the G to the other side to make it R equals div 1 by P0 plus G. Now we're all set, because we know div 1, we know P0, and we know G. So div 1 is 5.125. Oh, we took the G to the right, yes. So we know div 1, which is 5.125, we know P0, which is 68.33, and we know G, which is 0.025. So when we simplify this, it becomes 0.075 plus 0.025, which is 0.1 or 10%. So remember from the previous slide, we had R as 10%, which gave us the price as 68.33. Here, we wanted to find out R from a price of 68.33, and we got the same answer as before. Well, that's the end of Chapter 2, Part 1. Thanks for listening.